Hello, today I'm going to talk about rotation detonation engines, RDEs. So what is an RDE? Just imagine there's an engine which has a circular shaped combustor. While inside the combustor, combustion does not happen one at a time, but continuously racing around in the circle at supersonic speeds. Okay, that is the essential concept of rotation detonation engine. Okay. Now, in real life, all the combustion devices that you and I encounter, such as the internal combustion engine in our cars, jet engine on the airplane, they are not detonation engines. They are deflagration engines, which means the combustion process inside these engines happens at a speed that is lower than speed of sound. Rotation detonation engine on the other side, flame propagates at supersonic speeds, which is much faster than deflagration waves. So let's take a look at an RDE. So here I'm using an image from Air Force Research Lab. Now, as you can see here, fuel and air or oxidizer are injected into a circular combustion chamber. Now, instead of burning smoothly like a normal jet engine, they detonate, okay? They create powerful shockwaves that spin around the combustor, the chamber, okay? This detonation produces extremely high pressures and temperatures, which push hot gases out of the nozzle to create thrust. Let's take a close look at the physics inside the RDE engine. So as you hear, this is the detonation wave. Again, it propagates at supersonic speeds. Now, up in front of the detonation wave, which is the blue area, that's the fresh premixed gas made of fuel and oxidizer. As the detonation wave propagates into this unburned gases, combustion or detonation takes place, releasing heat. Now, 2, which is behind the wave, those are combustion products. And 3, as I mentioned, fresh unburned gas. And then 4, this is what we call contact surface. As you can imagine, behind the wave, there are several areas. And 5 is the oblique shock that's generated by this main detonation shock, okay? And is the wave propagation direction. So this kind of gives you a sketch of the physics inside a rotation detonation engine. Now the next question is, what are the applications of RDEs? Well, both in aerospace and defense. They could power future rockets, missiles, and high-speed aircraft. They may even work in space launch systems or in reusable vehicles designed to reduce costs. The military is especially interested in RDEs for hypersonic weapons, because they promise faster, more efficient propulsion. Now, RDEs are preferred over conventional engines in several applications due to higher efficiency, because RDEs can extract more energy from fuel because detonations produce stronger pressure waves than regular combustion. And it can be lighter and simpler in design because they do more with less fuel and smaller combustion chamber. And lastly, potential for higher speeds. The high thrust to weight ratio of RDEs make them great candidate for hypersonic vehicles. It's worth to mention that Purdue University's Zucco Laboratory is one of the very few university labs that's leading the research of RDEs. What you're seeing here is an image produced from Professor Miles' lab, where they use advanced optical diagnostics to look at the physical and chemical processing RDEs, which are very fast of data in 1 second due to the high speed of detonation. Professor Heister and his students are also studying RDEs. What you're seeing here is a image that shows the diamond shock structure from the plume of RDE engine, where the main parts of the RDE actually 3D printed. So what are the challenges of developing RDE technologies? Well, the concept itself is very amazing, but it's not very easy to build, to mature the technology. The biggest challenge is control, basically keeping detonations stable and continuous without blowing up the engine. That is the biggest challenge. Detonation waves, whether it's 1, 3, or 5. The other challenge is material limits, because the high temperature and pressure inside the RDE gives enormous, extremely challenging environment. So we need new materials that can survive in those conditions over a long period of time. Also noise and vibration, because the RDEs generate intense shockwaves, which can cause wear and tear on engine parts. And lastly, how do we integrate the RDEs into aircraft or rockets? That needs some revolutionary thinking.